we need to study about BiCMOS structures, because the main disadvantage of the CMOS technology is that CMOS technology is really good at consuming lower power and lower power and smaller size and all this other advantages of the CMOS structures. But when we come to the switching speed, when we come to the switching of the CMOS structure, the switching is not that good as the BJTs are meant to do. But when we have seen that in the BJT, the switching will be very good, and the switching means I'm talking about the passing of the signal at the output. It has to drive a large amount of loads at the output. That switching speed is not good with respect to CMOS. So that's why what they have done, the researchers has worked in order to combine both the CMOS structure and also by a BJT structure, whereas your the input part of the entire model will be designed with the help of CMOS, and only the output will be designed with respect to BJT. And this kind of structures we call as a BiCMOS structures. And now here in this particular lecture, we'll be studying about BiCMOS inverters. Means an inverter is been designed here with respect to CMOS technology and also BJT technology. So let us see now BiCMOS inverters. You can see now. See, this is the input part. This is the input part where it is being designed with respect to the CMOS technology, and this is the output part which is designed with respect to BJT technology. Since you are having both the technologies in one design, we call it as a BiCMOS structure. Whenever you have got both the technologies as a one particular design, we call it as a BiCMOS structure if you are using CMOS and BJT. So let us see now the operation of this one. The very approach of this BiCMOS is to exploit the advantages, characteristics of the bipolar and also CMOS technology. What are the advantages? The CMOS will be having low power consumption part, and also the smaller size is a advantage of CMOS. And coming to this BJT, it is having very good driving capability. It can drive very good output loads. So that's the main important thing, has an advantageous part. Hence, in BiCMOS design, the rational approach is to use the MOS switches to perform the logic function. This is a logic function where the MOSFET has been used, and bipolar transistor is to drive the output part. The bipolar transistor is mainly used to drive the output loads. The basic element here is that the inverter and the simple BiCMOS inverter can be imagined just like the one which is shown here. This is a simple BiCMOS inverter where you are having the input structure has been designed with the CMOS structure, and output structure has been designed with the bipolar transistors. T1 and T2 are the bipolar transistors, and T3 and T4 are the MOSFET transistors. So now let us see the operation of this one. The inverter circuit consists of two bipolar transistors, that is T1 and T2, and one NMOS transistor T3 and one PMOS transistor T4. Both the MOS devices will act as an enhancement mode devices here. Both are in the enhancement mode, means what? You are supposed to supply some input in order to create a channel first. So both are in the enhancement mode transistor, and the functioning of this BiCMOS inverter is just as below, which is given over here. Whenever you supply some input, Vin is equal to logic 0. If Vin is equal to logic 0, that is 0 volts is being supplied, then definitely what happens, the PMOS, that is NMOS, will be turned off and PMOS will be turned on. So now here, turned off. Now what happens to this one? That PMOS is turned on. Because of the PMOS is turned on, you can see it now. Whenever the NMOS is turned on, what happens to this one? T1. T1 is what? It's a BJT1. The BJT1 will be going into non-conducting state, and if the NMOS is turned on, the supplies the base current to the T2. You can see here now. If the NMOS is turned on here, if NMOS is turned off, what happens? The drain of this NMOS, the source of the NMOS is connected to T1. If it is connected to T1, what happens? The T1, it is not supplying any kind of input over here to the T1. Your T1 goes into off state. It becomes non-conducting transistor. That's non-conducting BJT. Similarly here, whenever the T4 is on, that the PMOS is on, definitely what happens? The channel is formed and the VDD flows through the output of this one. That output now try to trigger this T2. Now the T2 will be coming into on state. It is in the conductive mode. So that's what we have written here. Whenever the T4 is on, it supplies some base current to the T2, which now conducts, and which will be acting as a current source to charge the output load. So now if it is acting as a current source, definitely what happens, the charge will flow through this one, through the emitter, and that will be here, that will be stored in the output of the capacitance. That's a load capacitance. Coming to this one, whenever the input is equal to logic 1, if input equal to logic 1, here my input that is equal to VDD, logic 1 means VDD, there's a 5 volts, your T4 is off, there's a PMOS is off. Whenever the PMOS is off, then the T2, that's the second BJT, will not be conducting. Why? Because it is not getting any kind of base current. The base, you're not supplying any base current, so that's why the T2 will be off. Whereas when coming to the T3 is in the on state. Whenever it is in the on state, it supplies some base current to the T1. Now here T1 will be conducting. If it is conducting, then definitely what happens, it will act as a current sink. Why does it act as a current sink? Because whatever the charge is stored in the capacitor at the output part, that will be completely synced to this ground terminal. It will be synced to the ground terminal, means your charges will be discharged to the ground terminal. If a charges is discharging, means what? Your current is flowing, that current is getting synced to the ground. Syncing of the current is taking place. That's why this particular transistor will act as a current sink transistor, and this, in the previous case, this transistor will act as a current sourcing transistor. Why? Because it is storing some kind of input at the capacitor, so we call it a current sourcing transistor. And in this case, whenever the input is equal to logic 1, the T1 is turned on because of the base current supplied from the T3, and if it is turned on, then definitely what happens, the sinking of the current takes place. So that's why we call T1 as a current sink transistor. So these are the conditions and working conditions of a Bicmos inverter. Whenever the current sink takes place, and what happens, ultimately your output goes to 0, and that is nothing else but it is 0 volts plus saturation voltage, and that is equal to saturation voltage. That this saturation voltage will be always between these two terminals, collector and emitter of the T1. Now coming to the charging and discharging of load capacitance, we know that the charging and discharging of load capacitance is very fast because your T1 and T2 present at low impedance whenever it's turned on into saturation. Whenever your T1 and T2 are in present in the low impedance state. Low impedance state means what? It will be having less amount of resistance. Whenever it is having less amount of resistance, it means the current flow is very fast. Whenever the current flow is fast, means what? The switching of the transistors are taking very fastly. If the switching is taking very fastly, then definitely whenever these transistors are switching very fastly, the turning on of the transistors takes place. Because of the turning on of the transistor, the charge will be immediately discharged to the ground or synced to the ground, or else the charge which is stored in the charge will be sourced very fastly to the load of the capacitor. It means the sourcing of the capacitor takes place very fastly, and also the sinking of the capacitor takes place very fastly whenever these two transistors having a very low impedances. So coming to the next point here, the output levels, which is equals to this saturation region of this collector and emitter. If this is the case, if it is very small, then there definitely what happens, the base emitter voltage is almost equal to 0.7 volts. If this is the case, then the base voltage is equal to 0.7 volts in case of Bicmos inverter, and the inverter offers a very low output impedance and high input impedance. Here for this condition, you remember this one, ma'am. Whenever it is a VB is equal to 0.7, then the inverter will be having low output impedance and high input impedance. Even this is a very important objective. Whenever the transistor BJT's voltage, that is a B is equal to 0.7, then that particular transistor, here in our case it's an inverter, so inverter will be having a low output impedance will be low and input impedance will be very high. Because of that reason, it occupies very relatively small area, but still has got very high driving capability, current driving capability. And one important thing is that this inverter circuit has got high noise margins. Noise margin means definitely the BJT will be having very high noise. And since we are using the BJT in the Bicmos structure, it will be definitely it will be having a high noise. And this is another structure, alternate structures for this one, alternate Bicmos inverter. Here, constant DC supply is supplied between the T3 and T1. T3 and T1 were constant DC supply supplied. When it is supplied, then it means what? How can you say constant DC is supplied here? It means you are supplying some constant amount of base current. If you are supplying a constant amount of base current between T3 and T1, it means that your input is equal to logic 1. Why? Because until and unless this input is logic 1, the T3 will not be turned on. If T3 is turned on means then only it can supply some base current to the T1. So that's why there will be constant DC supply between the rails of T1 and T2, because it is having some current flow whenever the input is equal to logic 1. And this is not desirable arrangement. Completely, if it is completely constantly, if it is supplying some voltage over here, definitely what happens? If it is supplying constant input base current, definitely what happens? You cannot expect any kind of output at the output of the Bicmos inverter, because the reason is that whenever the T1 is turned on, your T1 will be completely converted or transformed into current sink